Hi, this is video 3 on expectation of expected value for sum, chapter 2021 combined. And we're looking at a coupon collecting problem. This is an application of waiting time to success, a linearity of expectation expression that we calculated in the previous video, but it's slightly different. So essentially the problem is telling us that there are 169 different flags that are packaged with each chewing gum by a chewing gum manufacturing company. How many gum must I chew to collect all of them, right? And let's assume that X is the number of gum purchases to get all the flags. So I really need to get all the flags. All I have to, so my success is going to be when I get a new flag, right? So that's how I'm trying to solve this problem. So X is the number of gum purchases to get all the flags. So X is essentially similar to what we did in the previous derivation, is to wait for first success, right? And then plus wait for second success, and so on until I wait for the nth success. And here something to notice that I'm waiting for second success from the first one, right? So I'm waiting for the second success starting from the first one, right? So this is how I'm defining it. And let's say each of these is another random variable, x1, as we said in the previous derivation, x2, and this is x of n, right? Now, let's say the success probability depends, and here it's a slight variation such that the success probability changes with n, right? Why? For example, and I'm like buying, and I'm considering that I'm buying each chewing gum one at a time, right? So think about my first success, right? The probability for success in this situation is going to be n over n. Why? Because whatever flag I get, right, it is a new flag for me, right? And so it is the success probability is going to be n out of all the n that I need to collect, right? And in this case, n is 169. Right, so let's assume this is my n, and the success probability is going to change from the first to the second to the third, because it depends on how many I've collected and how many I need to collect, right? And so P2 is going to be n minus 1 new flags, right? Because I got one when I waited for the first one, and like whatever I bought the first time, that is a success, right? So this is n minus 1 over n. Similarly, if there was a third one for P3, it's going to be n minus 2 over n, right? And so similarly for P of n, it is going to be n minus 1 over n, right? Because as I keep buying, this is the number of the successful ones that are left. So whenever I'm buying the same one, I do not count it as success, and I keep buying, right? So I know that x is x1 plus x2 and so on up to xn, right? And I also know from the definition earlier of xi, the definition is 1 over p of I, right? For each of these independent variables like x1, x2, and so on, right? So now the e of x of I is different for different random variables here. Right, so we are assuming, we are not really assuming, but for this problem, specifically for this problem, my P of I changes as I wait from first to second to third, right? So that's what we are calculating here. That's the slight difference between this problem and the one before, right? So here my probability changes, and so the expectation for each one changes. So this is n over n, right? And then the expectation for 2 is going to be n, so I'm just like flipping them, that's all, right? Because it's 1 over p of I, and then e x of n is going to be what? N, and this is just like n over 1 or n. Okay, so now we have the expectation for each of the random variables, and now I'm interested in calculating e of x, right? So that's not that difficult. By linearity of expectation, maybe you want to write it here. By linearity of expectation, the expected value of x is going to be n times, and this is just like by substituting these into ex1 plus ex2 and ex3. So I'm just like eliminating that step, although like we need to have it, right? Is going to be 1 over n plus 1 over n minus 1 plus 1 over n minus 2 plus and so on up to 1, right? And this is almost equal to, not exactly equal to, but this series, the value for this series is known, and this is equal to log of n plus 0.577. Okay, so if I calculate it for my n, which is 169, right, the expectation for x, or the number of gums that I need to buy before I collect all of these, comes almost equal to 965. Right, so essentially I need to buy 965 gum packs until I collect all these 169 flags. Okay, so this was video 4. In the next video, I'm going to talk about the expected value of a product.